Hello, we're going to be doing the Intermediate Math Challenge 2025 from Wednesday the 29th January. Today is actually Wednesday the 29th January, so I'm doing it on the day, which is fun. Been prepping classes to do it, and so it's fun for me to also try it. I'm going to give myself an hour. These are always a bit trickier because writing it on the screen is always a bit janky and doing it on paper. So I've actually, for the first time, bought myself some paper as well and a pen. So if I ever want to try something on a piece of paper, I'll do that as well. But we're just going to give myself an hour and see what I can do. So let's go. Okay, which of the following has a value closest to 0? So 10 minus 24 minus 14, 12 minus 28. Wait, is one of these just going to be 0? 12 minus 28 minus 16. 12 minus 30 minus 18. I could probably go the other way. That's minus 20. That's minus 22. Okay, this one. What's the remainder when it's divided by 13? Do they expect me to just do this? Don't know. Oh no, they're all 13s. Oh, that's fun. That's a 4. That's a 1. That's a 0, remainder 4. Oh, that's really fun. Enjoy. This diagram shows a square in a triangle the size of PRT. PRT, okay. That's 90, that's 60. That's 60 up here. 60, 90, wait, what's going on? These are the same. Wait, why can't I just see this? What? This is the same as this. Same as that. Oh, those are the same. Oh, so that's an isosceles triangle. Okay, so 90 plus 60, that's 150. 180 minus 150. Oh, this pen's a bit big. It's 30, so these are 15. So 15 is 30, minus 60, okay, that's 30. Okay, cool. That's actually a nice problem. Don't know if I did it a nicer way, but I enjoyed. Okay, let's go to 2. They're not cats. They have 12 more legs and they have tails. Don't know how many ears they have. So 12 more legs and they have tails. So 3 cats have 3 tails and 12 legs. No, so 4 cats have 4 tails and 16 legs. And ears is 2, so that's 8. Oh, I could just done, yeah, 8. Normal cats, rude. People without ears are normal. Not true. Okay, that's 1, so that's just 1. So it's 5 divided by a fifth, 25. 1 divided by 1 is 1. 1 divided by a fifth is 1 divided by 5 is a fifth, 5 divided by a fifth, 25. Positive number, so 3n is even. Which of these is on integer? Okay, I can just sub that in, I guess. 3n minus 1 plus 7. That's 3n plus 4. Okay, well, if I times it by... This is even. So when I times it by 3, it's even. Oh, no, sorry. This is odd. Odd plus even. No. Oh, wait, this is odd. Wait. Because odd... Wait. This is... Wait. Oh, it's an odd. Okay, even. Okay, n is odd, so that's even. An odd times 3 is odd, plus 2, that's odd, that's even. An odd times 3 is, okay, that's odd. Oh, wait, what am I doing? This is odd times odd, which is odd, plus 3, which is even. This is odd times even. This is odd times odd, which is odd, plus 2, which is odd. Okay, whoa. Oh god, I hate these. Okay. So we've got dolphin, shark, octopus, starfish. Okay, Now, the dolphin is saying that he can swim faster, and the shark that's not true. How can this work? How can you both be wrong? So I can't swim faster than you. That is true. Oh no, so that does work. You are right. Okay, if this is right, then octopus is right, which means both of these are wrong, which means that he can't swim faster than you. So he's lying, and that is true. What? Okay, we put a cap on 7, we come back. What is... that's 7 times 34 plus 1 over 7 times... no, okay, divided by... This is interesting. Divided by 17 times 14 plus 1 all over 14. So you cancel that, we've got 7 times 34 plus 1 over 7 times 14 over 17 times 14 plus 1. So that's, yeah, so then, like, if I just change these to 7s, good. Okay, well, these cancel, and this is a 2, so we've got 2 times 7 times 17 times 2 plus 2 over 17 times 14 plus 1. Oh, wait. These are both 17 plus 14. So that's 2 lots of 17 times 14 plus 1 over 17 and 14 plus 1. So it's just 2. Huh. Okay, it's just 2. Let's move this out of the way. Yeah, one of the things that I'm trying to do is just move things away as opposed to deleting them completely. But I did just randomly delete bits and pieces of that, but whatever. Okay, next. Colour 2 rows and 2 columns, so the colours. Another thing I'm not very good at was colour 2 rows and 2 columns so that the colour rows do not touch, not the colour columns do not touch. Okay, so there can be, if I do 1 here, then I can do 1 here, 1 here, so that's 2 options. And if I do 1 here, I can do 1 here, so that's another option. So that's, if I do 1 here, then I can do 1 here, and that's the same in reverse. And then for each of those cases, so that's 6 options. Oh no, wait. I'm being silly. Oh no, I'm being so silly because it's either there, or there, or there. 3 options. I need to find a better way of doing these faster. As opposed to just trial and erroring them. 3, and then also the coloured columns don't touch, so that's here. And then I've got 1, 2, 3, 4, 5. And then I've got, if I put this here, then I've got 1, 2, 3, 4, 5. If I put it here, then I've got 1, 2, 3, 4. And if I put it here, I've got 1, 2, 3. And if I put it here, I've got 2. So here there's, oh, I've got way too many. Because that's 10. I've got 5 times 2. That's 6. Okay. So that's 1, 2, that's 10, 20. So I'm seeing 20 times 3, which is wrong, because there's no way it's 60. So let's look at these again. There's either this option, 1, 2, or 3. 3 options there, and in each of those cases, there's 20. So there's this option, that's 1, 2, 3, 4, 5. Oh, okay. 5. Then there's, oh, it's just these. It's 5 plus 4 plus 3 plus 2. That's 14 times 3, 42. Oh, God, not sure. What's the value of that? Oh, that's nice. Let's factorize out a 20, 25. So this, that's yeah, there we go. Minus 1, minus 20, 24. So that's the square root of 20, 25. No, factorizing out 2024 now. So that's 2024, lots of 2024. So it's 2024. Yeah, I think that should have been more obvious, but cool. Oh, I didn't want to rub out, but whatever. Potentially that much 360. Increase each one of them by 1 of the multiple change and after 470. So 360 is 20 times 18. And then, well, no, that's not going to work. I think it's 9 times something, 9 times 40. Because then it's 10 times, oh, it can't be that anyway. Just divide by 8. But wait, 400, 4 times 100, can't be that, 40 times 10. But 39 times 9 doesn't give me that. I think it's going to be like, what's it divided by 15? I think that's 15 going to 360, 0 to 24. So 15 times 24, and then 16 times 25, I think. Yeah, so 15, 24 is 39. Cool. James Farm said, many cats to dogs are the ratio of cats to dogs. C to D was 3 to 5. There were 32 cats, but no dogs arrived. So, okay, at the start it's 3 lots of something, 5 lots of something. Then we've got 3x plus 32 to 5x. And that became 5 to 3. So 3x plus 32 over 5x equals 5 over 3. So 9x plus 96 equals 25x. 16x equals to 96. X equals to 6, I think. 6. So originally it was 18 to 30. And then we add 32. It goes to 50 to 30, which is 5 to 3. 18 to 30. So how many dogs are there? There's 30. Nice. The product of the first 3 numbers in the box is equal to the product of the last 3 numbers in the box. So 120 times 496 times x equals 496 times 360 times 48. Okay, so 120x equals 360 times 48. Well, this seems very easy, doesn't it? X equals 3 times 48. So it's 120 plus 24, 144. Huh. Okay. What's the sum of all those? Okay, so that's a ninth plus 2 ninths. Ninth plus 2 ninths plus 3 ninths plus 4 ninths. 7, 7, 8, 9, 10 ninths, which I think is 1.1 recurring. Yeah. Okay. What's the value of, ooh. Okay. So we're looking at this one. So if I take out 3 to the 4, and then I'm left with 3 to the 2 minus 1. And if we take out 2 to the 3, then I'm left with 2 to the 6 minus 1. And then I can difference of 2 squares. Well, this is 8. Oh, look at this. 9 minus 1 is 8. So those cancel out. So I've got 3 to the 4 divided by 2 to the 6 minus 1, which is 2 to the 3 plus... Oh, this is cool. 2 to the 3 plus 1 times 2 to the 3 minus 1. That's 9. So that's 2 of those. So that's 3 squared over 7. 9 over 7. Oh, that's awesome. That's an awesome question. David likes books. He only ever pays 99p or 1.99. Last month he spent £56.56. Legitimately, I think this is I think the fastest way to do this is to just times this by each of these numbers. 23 times £2 is 56. So it's definitely not this. Oh, sorry. It's definitely not. No. What's going on here? Definitely not that. Whoa, pen. Oh, it's on click. Definitely not that. 17 times 2 is 34. So, oh wait, if we do 7 times 9, it's a 3. 7 times 9 is a 3. Oh yeah, so 15 times 9 is a 5. 15 times 9 is a 5. I don't think it can be, I think it has to be 17, because 7 times 9 give you a 3, 7 times 9 give you a 3, and that gives you a 6 at the end. Let's actually just try that. So 17 times is 34 minus 17p, so £33.83, and then 17 times 1 is 17, so that's 16. Oh no, that's wrong. Oh wait, because it could just be, he could do even more of those. Oh, because it's not saying there's 17 of them. But yeah, I think the only thing that's divisible by 3 is a 7 times 9, because 3 times 9 would be a 7, 8 times 9 would be a... Oh no, wait, that doesn't matter, does it? Because it's not 17 of each. Okay, things that... The 9s end in a 1, a 9, no, they can end anything. 34, and how can I get to... Okay, let's, yeah. 34, so that would be 22.50. I can feel there's better ways of doing this. So that's missing 44p. So I'm going to need £44 worth. I don't think it can be 17, because I need another 23 books. He needs to buy at least 23 books. And if you take away 23 from this, that gives you 60. I don't think it's 17. Okay, let's try 15. So 15. So 15 times £1.99 is 30 minus 15, so it's £29.85. So now he needs to spend another £27, but that would take away, but £27 would get him to 56.85. But then he's also, that's minus 27p. 27, oh, I don't think that's right either. Okay, let's try 13, so 26, £25.87. So he needs £31, so that's 31 bucks. If you minus 31p from this, okay, it's 13. Ooh, tricky. Oh my god, wait, where's all my answers gone? That was 30, that was 144, that was 1.1 recurring, that was 907. Okay, dark green paint is made by mixing blue and yellow paint, so 6% is blue. So dark green is blue, yellow, 60% blue. So 6 to 4, so 3 to 2. Light green is mixing blue to yellow in the ratio 6% yellow, so 3 to 2. Paradox is dark light paint, so the 60% of the mixture is dark paint. So, okay, we've got 60 to 40, and we've got 40 to 60. And we're going to mix that together such that 60% is this. So the ratio of that to that is 6, is 3 to 2, so it's 1.5 more of this than this. So if we just times this by 1.2, that's 90, 60 plus 40 is 130, 120. So it's 13 to 2, 12? Not sure. Not sure. Think 13 to 12. Okay. What's the distance between the 2 points where the circles intersect? Those two distances. Okay, well, the radius is 13. So I've got a little isosceles, so that's 13 and that's 13. Actually, let's zoom in on that a bit more. Let's make this pen a bit smaller. So we need this, got this, we've got this and this. This is 13, this is 13. Now, this distance is, oh wait, that's 13, that's 13. So this distance here is 10. So this distance is 5 and 5. Okay, so if this is 13 and this distance is 5, we just need to find this distance. Oh, it's 5, 12, 13. Would you look at that? So that distance is 24. As soon as you have 5 and 13s, Pythagorean triples. Okay. Rob playing some photos. Okay, I'm actually I might move these down. Give myself more space. Damage to rub things out. Ooh. Okay, so pen space. Rob pasted 55. Rob 45. Rog. Okay, so B 45, G 46, Y 48. Oh no, where's 46 comes from? 51. Okay, so one of them is a multiple of 3, which they all are. So that's a multiple of 3. So we've got one that's 3n, one that's 4n, and one that's 5n. Okay, so that's 5n. So he did, and that's 4n, and that's 3n. Okay, so one appeared twice as many points. So this guy, if we divide it by 3, so he's 17 and 20 and 34. He's 9 and 36. And he is 14 and... oh no, 24. He's 12 and 36. So who painted the most in the morning? This guy. That's interesting, because this one's only divisible by 5, so he does 9 and then does 4 times more, which is 36, which makes 45. Here he does 17 and then twice as many in the afternoon. So he does 17 in the morning, 34 in the afternoon, gets to 51. Can't divide by 4. This one, he does 12 in the morning, 36 in the afternoon. Is that 3 times as much? Yeah. So the most in the morning by far is Rog. But I think people would have guessed that anyway, just because 51's the most. That's interesting. The large variety y of x. Okay, so that's that. So this angle here is 180 minus y, but that's also the same as 180 minus x over 2. So that means we've got 360 minus 2y equals 180 minus x. We've got 180 equals 2y plus x. And we want y over x. What's the largest possible value of y of x? The largest possible value. So we want to make x small and y big. X small and y big. So this was 2. X was 2. Y could be 178 over... oh, wow. 2, which is 89? No, that doesn't work. Okay, if this was 4, then this would be 176 divided by 4. Yeah, okay. 176 divided by 4. Well, if you divide it by 0.4144. Oh, wow. I've got 44, but that's wrong. Okay, so this is 180 minus y. And these two are 180 minus x. Add those two, but then you divide it by 2. So it's this. So 360 minus 2y equals 180 minus x. So 2y minus x. There we go, found the mistake. Okay. 2y minus x. So if this was 2, 182. No. So this was 4, 184. 184 over 2 is 92, which is 46. So 46 over 2. Hold on a minute. If y equals to 92 and x equals to 4, then we've got 186. Oh no, sorry, that should be 184 divided by 2 is 92. So yeah, 184, okay. And then we've got 92 over 4, which is 423. Can I get, hold on a minute. No, y, oh wait, y over x is an integer, so y doesn't need to be an integer. No, it does, because x is an integer. (180 plus x over 2y equals 0). Oh, no. 180 plus x over 2 equals y. So I've got 180 plus x over 2 over x. And we're trying to minimize that. So we've got 90 plus x over 2 over x. So we've got 90 over x plus a half. We're trying to minimize that. No, we're trying to... I'm going to come back to this one, but I think I might have got it right. Okay, 8 to the 8 divided by 5. 8 divided by 5 is 2 to the power of 3 to the power of 8, which is 2 to the 24. Now, if we just look at last digits, I think, so the powers of 2, I probably could have done this just straight off the powers of 8, actually, because 8 is there, then times 8 is 64, then times 8 ends in a 2, then times 8 ends in a 6, then times 8 ends in an 8. So 8 to the power of 1, 8 to the power of 1, hello, what's happening here? 8 to the power of 1 ends in a 1, hello, what's happening? 8 to the power of 1, 8 to the power of 2, 8 to the power of 3 ends in a 2, 8 to the power of 4 ends in a 6, so 8 to the power of 8 will end in a 6. When I divide it by 5, the remainder is 1. Cool. Half an hour. The sphere radius 4 and the sphere radius 6 are placed on horizontal surface so they touch. So we've got a circle and a circle. And what's this distance? Now this is 16 and this is 4. So that is 4. Okay, I've drawn this so bad. That's 4. That's x. That's 12. Oh, I know what this length is as well. That's 16. Mate, it's all about the radiuses and the drawing it and the thing. Okay, so we've got 16 squared minus 12 squared equals x squared, and then I need to square root it. So this, is that a Pythagorean triple? Is that, I don't think so. So that's 16 plus 12 times 16 minus 12. So it's 4 times 28. So it's 56, 112 equals x squared. Oh, I've got this wrong. Oh, this is 20. Because it's 16 and 4. Isn't 20, 12, isn't this a Pythagorean triple? Isn't that 9, 12 and 20? Or something? Or 16, 12 and 20? Isn't it 16, 12, 20? But let's see. Okay, let's just do this again. So this is 32 times 8 equals x squared. So actually, I don't actually need to do this because this is 8 times 8 times 2 times 2 equals x squared. It is 16. X is 16. Oh, great question. A classic of the genre of when you've got circles, drawing the radiuses and see what happens. Okay. 23 is the point inside a circle, point inside a rectangle. So we draw it, let's make it bigger. P from one corner of the rectangle is 5. P to one corner is 5. Does opposite corner mean there? Well, it's just Pythagoras, right? Wait, no, I'm losing my mind. Why is it not just 9? What does opposite corner mean? What does opposite corner mean? It's not that. It must be that this is 14. Because what does opposite corner mean? Because in this case, it's the easiest question ever, isn't it? Oh no, because these aren't. There's no saying that this is. It's not a straight line. Oh, okay. No, yeah, we can. Okay. Well, I'm like wiggling it around. Okay, so this is A, this is A, this is B, this is B. This length, this length, and this length, this length, and this length. Okay. A squared plus B squared equals 19 squared. And then also so that's, wait, that length is 5. There's some interesting stuff in here. Oh, there's interesting stuff that I might draw this on a piece of paper, which I know is not super good for YouTube, but I'm just going to redraw this because I feel like there's something interesting in here that I'm missing because my drawing's not very good. So this hypotenuse, it splits it. Let's go 5 and 14, and then this distance is 10. Could that distance be 10? That distance, okay, and then that distance is 10. I'm literally just drawing it again, but a bit less bad. And now we need to find this distance. This is interesting, like the ratios and stuff. This is cool. Now if I just split it up like this, so that's 5, that's 10, that's 14, that's x. So this feels like all sorts of Pythagoras. A, B, B. So A squared plus B squared equals x squared. A squared plus C squared equals 5 squared. D squared plus C squared equals 10 squared. Yeah, I've got something going here. That's 14 squared, and we know that A plus D squared plus B plus C squared equals 19 squared. So that's A squared plus 2AD plus D squared plus... Okay, I'm going to write this on the screen as well, which will take time, but it's fine. Here I've got 2A squared plus 2B squared. Okay, this is what I've done, is I'm writing, actually, if this is A, then this is A. And if we... Okay, this is interesting. So we've got a line across here where this is 5 and this is 14. And we've got a line across here, this is 10, and we're trying to find this. Now, if I cut this into rectangles like this, I start labeling things. Let's call these A, these B, these C, and these D, like that. Then now I can form loads of equations. So A squared plus B squared equals to X squared. What am I trying to find? We're trying to find... Ah, this is really interesting and I don't have enough time. A squared... Oh. Come on. Come on. Okay, well, I'm going to do that for each equation, but I also have that A plus D squared plus B plus C squared equals 19 squared, and I think that's enough information to find that missing value, to find a squared plus b squared. If I add all of these together, that's 2a squared plus 2b squared plus, hold on, if I look at, so here I've got a squared plus d squared plus b squared plus c squared plus 2ad plus 2bc equals 19 squared. Now, d squared plus c squared is 14 squared. We're trying to find a squared plus b squared. X squared. Oh, there's something happening here, but I'm not getting it. Plus 2c squared plus 2d squared equals 5 squared plus 14 squared plus 14 squared, so that's 25 plus 100 plus, what's 14 squared? 196. So that's 296, so that's 321. 321. So a squared plus b squared plus c squared plus d squared equals 321, but c squared plus d squared is 100. So a squared plus b squared is 121, so it's 11. It's 11. It's 11. Okay. What I did, a squared equals c squared, I did c squared plus a squared equals 5 squared. I did c squared add d squared equals 100. And I did, which is 10 squared, I did d squared plus b squared equals 196. Then I add them together, and you get two lots of a squared plus b squared plus c squared plus d squared equals all of these added together, which is, oh no, I've messed up. Okay, well, it's 321 plus x squared. Now, c squared plus d squared is 100. Oh, I'm really glad I wrote this out because I got this wrong. So two lots of a squared plus b squared. Remember, that's just x squared. So we've got two lots of x squared plus 100 equals 321 plus x squared. Now I can solve. Okay, so that's 2x squared plus 200. Oh, I get the same thing. Oh, interesting. Equals this. So I've got x squared equals 121, so x is 11. Okay, wow, I somehow made a mistake. Okay, I don't think you can really see this, but I just drew it out. Okay, wasted time. Ooh, okay, it's another simultaneous equation. So 2 white and yellow equals 5. 2 white and 3 red equals 1050. 3 yellow plus 2 red equals 11. What's R plus W plus yellow? That, okay, if I add them all up, isn't this just simultaneous equations? If I just subtract these, I get 3R minus Y equals £5.50. So that's just half of that. Yeah, one sec. 3y plus 2r equals 11. When I'm trying to find, and then minus y plus 3r equals £5.50. There's something about those being half of it. But whatever. Let's just do it the boring way. So that's a 3, that's a 9. So I'm just times it all by 3, and that's a £16.50. Then I subtract them, and I get 7r equals 5.50. Oh, wait a minute. Oh no, I add them. 11r equals £27.50. So r equals £27.50 over 11. So So 0, 2 remainder 5, 5, 0, £2.50. So R is £2.50. So 750 Y is £2, and W is £1.50. I could have done this better. Yeah, altogether it makes £6. Could have done that better, I think. So let's just check that. So £3 plus £2 is £5. £3 plus £7.50 is that. 6 plus 5. Yeah. Weird. Just another simultaneous equations question. This one also feels like simultaneous equations, this last one as well. Interesting. What's the area of this? I'm sure I think there's just an answer to this, but like a way of looking at it and just knowing, but whatever. Oh, wait. Oh, wait. Got 14 minutes. Oh, I need to go back in time and do, you know what? Let's go back and do 7 again. Whatever this one I missed out was. 7, okay. So that's dolphin swimming faster than shark, which is if they're both wrong, how can they both be wrong? That's what I don't get. That means they swim at the same time. So, dolphin's saying I swim faster than you. So, dolphin faster than shark. Shark saying shark faster than dolphin. If they're both wrong, then they swim at the same speed. So if that's true, and the starfish saying dolphin was, yeah, you're right, they both swim at the same speed. So they could all be true. Or, if this guy's not true, if he's wrong, then he's right, which means he's wrong, and he's wrong. So it could be 1. But they could all be right. It depends if they can swim at the exact same speed, I think. I think it's either 4 or 1. I don't know. I'll take the loss on that. I'm not sure. What am I doing? I'm looking at this last question. Okay. Let's draw it big. There's something in here that I don't think I'm getting, because these are the same area. Like, I feel I could just grind this with so much algebra. Oh my god, wait, why is this A plus B? What have I done here? This is just C. Oh, this is C plus D. Okay, so let's actually do it here. So AD over 2 is, so AD is 12. AD is 12. C lots of A plus B is 12. B lots of C plus D equals 10. And we're looking for C plus D times A plus B minus 17. So we're looking for AC plus BC plus DA plus DB. Now we're taking away 17. So we need all these. So already we know AD is 12. And we also know that AC plus BC is 12. So AC, that's also 12. And BC plus BD is 10. So this plus this is 10. Okay, one sec. We've got AC plus BC is 12. BC plus BD is 10. We've got AD is 12. If I add these, am I missing any? I've got 3 equations. I should have 4 equations. Okay, so if I add these together, AC plus 2BC plus BD equals 22. So I'm missing something. So if that's true, we're looking for AC plus BC plus BD plus AD. So AC plus BC plus BD, that's 2BC. I've got an extra BC hanging around. AD is 12. C times A plus B is 12. B, one sec. AD equals AC plus BC. So really I've got 2 lots of AC plus BC plus DB minus 17. AC plus BC is 12, so that's 24 plus DB minus 17. So we just want to do DB minus 17. And DB I feel like I have enough information. I mean, I could also just do loads of janky substitution, I think, and sort it all out, but we're trying to find A plus B times C plus D. And then we're taking away 17. So that's AC plus BC plus DA plus DB. So I want all of those. Now what I have is AC plus BC, AC plus BC, which is 12. I've got DA, which is 12, but I don't have DB. But I do have that BC plus BD equals to 10. So how do I get rid of BC? AC plus BC equals to 12. Missing something obvious, I think. There must be a general formula for this, like a way that it just works. Like, that's also 6. And then that bit's also 5, and then that bit's, this bit's 6. Over here, that's 6. This bit, these bits, got 5 minutes, and I don't know. I'm going to try on a piece of paper. I'm just going to literally be writing the exact same thing down, just hoping that somehow the writing it on a piece of paper will be better. Okay, so this is 5, this is 6, and that is 6. That's A, B, that's A plus B, that's C, that's D, that's C plus D. So C plus D times B equals to 10. So that means CB plus DB equals to 10. I also know that AD equals to 12. And I also know that AC plus BC equals to 12. So I've got this. I'm just writing exactly what's on the screen, just again. What I'm looking for is the whole area, which is A plus B times C plus D, but then I'm trying to get rid of 17. So that's AC plus BC plus BD plus AD minus 17. So I want AC plus BC plus BD plus AD minus 17. Oh, I've only got 3 minutes. So CB plus DB, CB, this middle bit is 10. AC plus BC plus BD plus AD. Okay, BC plus BD is 10. AC plus BC is 12. This is like... Hold on. BD has to be 2 less than AC. BD is AC minus 2. Does that help me? I don't know. And then we've also got AD, that's 12. This should be really easy, I feel like. I've basically got AC. I'm trying to find AC plus BC plus BD plus AD. This is 12. This is 10. And this is 12. So what does that mean? Well, it means that this bit, that's 22, but there's 2 of those. So this, I mean, 7, 5, and 5. It could be anything. Oh, I'm out of time. So this is just AC minus 2. That's just a bit smaller, this by 2. So really we've got 2AC plus BC plus AD. Well, that's just 12. So really we just need 2AC plus BC minus 5. Just coming up with one too many of something. Okay. Couldn't get this last one. Don't know. Gonna take a sweet gamble at 13. Taking a sweet gamble at 13. But I actually don't know how to do that last one. Feel like I'm close. Feel like this is the thing, and then I just Don't know. Okay. We're out of time. Those last 40 seconds I don't think are going to give me anything, because this is what I'm trying to find. And I feel like I'm just missing something very obvious, but it's all good. Okay. I'm going to pause this. Thank you so much for watching. Been super fun. Actually, very enjoyable. Lots of simultaneous equations. 23 I found particularly tricky and interesting. I think I got 20 wrong. Also, might have got 19 wrong. Lots of circles and radiuses. Lots of simultaneous equations. Might have got 16 wrong as well. Oh no. Might have got 17 wrong as well. Didn't feel super confident about that. Sort of just guessed it a bit. The other ones felt pretty good. Had a great time. Okay, I'm going to save it. The results, the mark scheme's not out yet. When it's out, I'll mark it. I'll cut the two videos together, and then I'll post it. Thanks for watching.